In this video, I would like to solve this equation, and I'm going to do it by factoring. And maybe you caught the first video when I solved this a traditional way by distributing, getting all the terms on one side, and then factoring by grouping. Well, I would like to try a different strategy so I can kind of accentuate something that's possible when you're dealing with expressions. So instead of distributing initially, I'm going to go ahead and leave this as a whole term, 4x times 5x plus 6, and I'm going to bring it over to the left side because I know in order to solve this by factoring, I still need it equal to 0. So let's go ahead and do that. So x to the 5th, and then we're not distributing. So I'll just kind of keep everything in its place, and then minus 4x times this quantity, 5x plus 6, and that equals 0. Okay, I'm going to go ahead and switch these two terms around so I can get these 5x plus 6's next to each other. So I have x to the 5th minus the 4x cubed, and then plus x cubed times this quantity, 5x plus 6, and then minus 4x, again times this quantity, 5x plus 6. And I'm going to do a thing, we're going to group still, but we're going to do it an interesting way. Okay, so we have this first group and then this second group. So it looks like we can pull an x cubed out here, and I'm left with x squared minus 4. And here, I'm going to go ahead and factor out this 5x plus 6. And what I'll have left is x cubed minus 4x. Okay? Well, it seems like I didn't really do much in order to get this going, but notice here I have a greatest common factor of x. So let's go ahead and pull that out of that second set. So I'm going to say plus x, and then 5x plus 6, and then x squared minus 4. Well, okay, well here I have an x squared minus 4, and here I have an x squared minus 4, and I'm kind of working with just two terms. So let's go ahead and factor out this x squared minus 4. So x squared minus 4, so what will that be that I'm left with? Well, I'll have the x cubed from right here, and then I'll have plus x times 5x plus 6. Okay? Well, if you look at here, once again, I have that x, greatest common factor, that I can pull out. So let's go ahead and get him out front. X squared minus 4, and then x squared plus 5x plus 6, because I took this x out here. Okay, well this looks now like a great place to be because I can use difference of squares here, and this is a really nice quadratic trinomial. So the difference of squares will end up giving me an x minus 2 and an x plus 2. And then this quadratic trinomial, I'll need to factor this way. The leading coefficient is 1, and that's really nice. So I need two numbers that multiply to positive 6 that add to positive 5, and that'll be a positive 2 and a positive 3. And you'll notice, of course, I got a couple factors that are the same. So let's go ahead and rewrite this whole thing now. And we have the x plus 2 factor squared. So it looks like this. This is my complete factorization. So let's go ahead and scroll through and see kind of where we got where we did and how we went about doing it. So I noticed that I had this 5x plus 6. So instead of distributing, I went ahead and put them side by side, and then I factored them out. So I had my 5x plus 6 that I brought out. And then after I did my greatest common factor of x, I was actually able to do this, pulling the x squared minus 4 out again. And then I was left with this great factorization, which I could continue and finish up. So let's go ahead and finish the problem. So I have 1, 2, 3, 4 unique factors, and they're multiplied together to give me 0. So of course the 0 property of multiplication says that, at least one of these has to be 0. So I'm going to accommodate for all of them and say they all equal 0, and then just solve all these equations independently. Well, x equals 0 is already solved for. So when I add 2 here, I'll have x equals 2. When I subtract 2, I'll have x equals negative 2. And when I subtract 3, I'll have x equals negative 3. So here are my four values. X equals 0, plus or minus 2, or negative 3. And again, that's just kind of a different look at this equation. You could have caught the first video where we just distributed everything through and then factored it straightforward. But I kind of wanted to accentuate a different kind of strategy that you can use. Maybe that wasn't the greatest strategy for this example, but it is a strategy that's out there that is good to use with a lot of a little more difficult expressions. So there's our answer for that one.